All right, we're going to do a double integral over a non-rectangular domain. So this is our new challenge, is how to integrate over something that's not a rectangle. That means our bounds of integration are not going to be constants. They're going to be functions of x or y. So this is our domain. We're going to integrate the region that's trapped by these two functions, or these three functions. The line x equals 3. Y equals the square root of x, and y equals 1 over x. The region trapped in there is this shaded region here, and we call that region R, and we're integrating. We see in the notation that we're integrating over R. That means that's our region for integration, and this is the notation for our double integral. So we want to decide what kind of region we have, if it's x first or y first, and this is a good this is a good y first region, because we can take a slice that goes from y equals 1 over x down below up to y equals the square root of x up above, and we can take that slice and we can integrate that slice, and then in x we can go from whatever this x value is right here over to x equals 3, and it's like adding up the effect of a whole bunch of those slices. We add up the effect of all of those slices. So we start with that vertical slice, and in order to get that x bound, we do need to know what this value is right here. To find it, we set these things equal to each other. So square root of x equals 1 over x. If I, multiply both sides by x, that's x to the 3 halves equals 1. So x is 1. So this point here is x equals 1. So we know that this shape goes from x equals 1 over to x equals 3. In y, it goes from y equals 1 over x down below up to y equals the square root of x up above. So we're ready to do this. We can set this thing up now. And our endpoints of integration are, we start at the bottom, and down here we have y equals 1 over x. So y equals 1 over x up to y equals the square root of x as an upper endpoint of integration. The function we're integrating is x squared y. We're going to go y first, and then we're going to go x, and we have x going from 1 to 3. This is now set up appropriately. The inner endpoints are functions of the other variable, that's normal, and the outer endpoints are constant, that's necessary, right? The outer endpoints have got to be constant, and the inner endpoints could be functions of a different variable. So we go ahead and we integrate. We have x going from 1 to 3, and in y this looks like x squared y squared over 2. We integrate the y to y squared over 2 from y equals 1 over x to y equals the square root of x. So we have an integral from 1 to 3 of x cubed over 2 minus 1 over 2 dx, and that looks like x to the 4th over 8 minus 1/2 x from 1 to 3. So this is 3 to the 4th over 8 minus 3 halves minus 1/8 minus 1/2, and that all comes out to equal 9, which is the volume under that surface above the region that was indicated.